Hi guys, today we're going to be looking at our plate boundaries. I'm going to draw some up now. I'm going to start by drawing some oceanic crust. Now remember, oceanic crust is really quite thin. It's only about 5 kilometers thick. And at points like this, we've got convection currents in the mantle, or in the asthenosphere I should say, that are moving our plates across. Remember in that last lesson we talked about how friction between the moving asthenosphere and the crust itself can cause these plates to move. So we've got our movement, and here we've got our first plate boundary. This is called a divergent. Here the plates are moving apart. Why is it moving apart? Well, it's simply moving apart because it has to. The convection currents within the asthenosphere are moving this way and stretching and pulling the crust apart, forming a feature here called a mid-ocean ridge. Cool. All right, let's keep our crust moving on its journey. And here we're going to move it along. Then all of a sudden we're going to take a big dip here. We're certainly going down a long way as our plate moves downward. Remember, our plate here is still moving in this direction. But for some reason, it's taken a sharp turn. Why is it taken this turn? Well, it's gone this way because we have another large plate here. This plate is a thick plate called a continental plate. Here we've got this plate is still moving this direction, but this plate, well, it's moving this direction. It's called a convergent boundary. And something unique happens here is this plate moves down. This is called subduction. All right. Now, the reason this plate moves under is because it is denser. It is lighter, but it is made of much denser, heavier materials. Just get the right pen to use. All right. Oceanic crust subducts because it is denser. Good. So, as it subducts, we get a whole load of features occurring here. By the way, I should be drawing at the same time our water. Let's draw in the oceans, because it's important that we recognise that they're there. This is the ocean. How do we know it's the ocean? It's got fish in it. There's a little fish. Oh, that is the bad fish. There's a little tadpole. And another fish there. Oh, and a boat. There we go. With a little sailor in there. There we go. So, there's the ocean. That's not to scale, by the way. So here we have our ocean, and this ocean would be, let's say, for example, about 8 kilometers thick. The continental crust here would be about 30 kilometers, and our oceanic crust here is 5 kilometers thick. So it's not quite to scale, but hopefully it should demonstrate well now. All right, so we've got our oceanic crust and it's moving downwards. Now, as it moves downwards, it creates a deep part of the ocean called a deep ocean trench. Ocean Trench. Now you might have heard the Marianas Trench, just north of the Philippines. The Marianas Trench is the deepest part of our ocean. Can you find out how deep the Marianas Trench is? Please do. So the Marianas Trench is at a subduction boundary where oceanic crust is forced under some continental crust. Right, let's look at what happens here. As this crust makes its way downwards, it creates a lot of earthquakes. So, these are earthquakes. Now, the Boxing Day tsunami was caused by an earthquake at one of these zones. So we have our crust, it's moving downwards and it's making lots and lots of earthquakes. Something else really interesting happens, and it happens about here at a depth of about 80 to 100 kilometers. As this plate is getting pushed under it deeper and deeper, it actually starts to release a lot of water. And when it releases water, it melts the magma in the asthenosphere. Melting magma. That makes it different in density. So the magma starts to rise up. Well, that's a bit of a munted looking magma. And it rises up through the crust to it gets to the surface and forms a volcano. So let's write that down. Magma is melted by water from the crust that magma rises to form volcanoes. Oops, forgot the E. So all of our volcanoes, most of our really violent, horrible, terrible volcanoes in the world, things like Mount Pinatubo or Mount Fuji or Mount, oh gosh, just trying to think of some more volcanoes, Mount St. Helens. These are all very active and very violent volcanoes. They form this way. All right, so there we have our first part. We've got our divergent boundary where the plates move apart. We've got our convergent boundary where one plate moves under another. Let's look at the next step, and we're going to do that, we're going to move our image along, and I'm going to start over this side. Let's get a fresh piece of paper, and let's continue our continental crust. So remember, this continental crust form part of the volcano, and we're going to move it along. But what we're going to do is we're actually going to collide it with another piece of crust. So we're going to have this one colliding. I'm going to move this on a little bit further. So let's see what happens when we push these two together. Well, we end up with a situation just like if you squashed two Mars bars together. I suggest you try that, it'd be really good. Your parents will love it too. We end up with a big smooshy mess. We have one plate, this one, here, and it's moving this way. Another continental plate, it's moving this way. When the two collide, they create a big mushy mess. This is a convergent boundary, but it's a collision. So, what happens here? Well, this is called a mountain building episode. We get a whole heap of earthquakes occurring in this region. Why? Well, if you think about what's actually happening, is everything's being squashed together. And the earth is being crushed and pushed apart. An example of a location where this is happening, well, if we think about this very tall peak here, we know this would be something like the Himalayas. All right, so there we have two main types of plate boundaries. Let's put them together and see what they look like. Okay, so here's our different plate boundaries. We have our divergent boundary here and plates spreading apart to one plate being subducted under another, causing some melting and forming a volcano. We've got earthquakes occurring as this plate is being pushed under another. As we move along and two continental plates collide with each other, they crash together to form a mountain building episode in a collision, forming features just like the Himalayas. All right, let's do our last plate boundary. And here is our continental crust extending again. And this time, I'm going to draw a straight line. I'm going to draw it in black, straight down there. And then I'm going to continue along. What is this black line, you might ask? Well, let's look at it from a bird's eye view. And I'm going to draw here what it looks like from bird's eye view. So you can imagine we have our plate, our large part of the earth, and in the middle of it we have a line. Now what's happening here is this plate is moving in this direction and this plate is moving in this direction. The plates move, it's called shear movement, and this is called a transform boundary. It's where the plates slide past each other. Place where this happens, the San Andreas Fault, and that's in California, US of A. All right, so there's our three main plate boundaries. We have divergent boundaries, convergent subduction, convergent collision, and transform boundaries. They all form different types of features, and I've drawn a few of those features on here for you today. All right, good luck.